All right, hello. Hey, Linux.exe. How are you? Hope you're doing well on this lovely, lovely Friday. I know I'm doing well. I'm looking forward to doing a bit of casual art-based programming and just heading out for the weekend after that. That's basically my plan. Good to see you here. Hopefully we see a few people pop into the stream. That might be fun. But either way, I'm in a great mood. And I hope everyone else is too. All right, let's see. I've been working on a few more tools here. Let me see. Show you the grid for a minute. We've got here, let's gen a grid. It should work. Hey, look at that. It's pretty fun, I think. Coming along pretty nicely, if I do say so myself. Let's do let's shrink this just a little bit here though. Let's try that. Yeah, they look awesome. Thank you. Yeah, I'm pretty happy with how things are turning out. It's all coming up just fine. I figured out, I don't know if you're still around when I was working on it, but I had a triangulation thing, algorithm that I was struggling to figure out how to get it to work, but I figured out the problem and I sorted that out. So all of the pieces are in place. It's just a matter of kind of tweaking how things look a little bit. And then start messing around with a few different ideas. Here's another idea I had. This uses almost the same code, but I've got sort of variations with different ideas going on. So yeah, I just, things are coming along pretty nicely. I'm pretty happy with it. I think it looks pretty sweet. There's also, excuse me. Oh, let me, I think this is the wrong size. Let's see, did I do the sizing correctly here? Yeah, there we go. I had this other idea. What was it? Oh yeah. Yeah. 4, 6, 8, 10, 12, 14, 16. Let's try that. I think this will work. Whoop. Oh. So this is kind of the fun thing. Once you have things in place, you can kind of just go ahead with different ideas and see what turns up. So, I don't know, this looks kind of cool. These four here, how they kind of pinch into a single line like that for any multiple, any even multiple. I think that's pretty cool. But then I've got other stuff. Let's try, I don't know if I finished this. Let's see. Let me try this now. P hex grid. I don't remember if this will work. Oops. Yeah, let's try that. I don't remember this. Well, let's figure it out. I don't know that I actually finished this hex grid implementation. That's the thing. We shall find out. Oh, kinda. Something's wrong with this here, but what am I even trying to prove to myself here? I don't think this works yet. 12. Why is that? Okay, well, let's add that to the list of things to fix. Okay. Okay, what was it? Oh yeah, so, oops. I just have to add this here to do, finish p/hex grid implementation. Doesn't work properly yet. And then here to do add convex call algorithm to svgclj dot utils or svgclj dot transforms, maybe a new ns, to do add Delaunay triangulation algorithm. I don't know if that makes sense to have in that namespace. That maybe not. I'll have to see about that. It might be good to have those out on their own, like in their own third library. I don't know. I'll figure that one out. That's fine. But for sure, whatever. That is okay. For sure this here, the hex grid thing, I can for sure implement that. That's actually pretty helpful for other work. Okay, so all right. Let's get a bit of visual in here. I had this idea to pull FFmpeg in here to do an animated version of this sort of thing where the grid points move. I think that could be pretty cool. I'm not going to worry about that yet, though. I want to finish. Well, let me clean this up now, actually, just so I get. Oops. What have I done now? Oh. There we go. Yeah. All right. I am pretty happy with that so far. I could also... For this idea here... Oh yeah, I have a focal point that I can adjust as well. I don't know if this will look good or not, but let's see. I mean, maybe it will. Kinda. Uh-oh. I just crashed Emacs, apparently. Ridiculous. That's annoying. But fine. All right, well, let's load file, source Cypress main. That should work, right? Yes, good. What? Is it all gone now? Ugh! That doesn't make any sense. Shoot, now I'm a little bit paranoid here. Okay, seems to be like maybe I missed one thing. Okay. Shift try by count points. This should be points. And this FB, function B, will be if, no, do this please, yes. If LC exists, then function B is this, basically, with LC, otherwise it's with LB, and that should be, points, shift points. Oh, I also need to make sure shift, annoyingly, I don't know what happened here, but it must not have saved as frequently as I thought, but whatever. Luckily, I'm not that far off. Let's do this. Util functions up here. So we got shift working. That should be fine. Let's pop back down into this, check fences here. Perfect. Okay, so let me check here. Quad is this. Def. Okay. So now I want to do fence lines quad. And then N is 3. Okay. So here, now I have to figure out what's gone wrong with this. Oh. There we go. The only thing is, I thought that I had the situation where it should occasionally go horizontal instead of vertical. Oh, here, this is why. I need to take rand int of count points like this. Oops. Then need to redo this. Then that should... There we go. That seems to be working the way I want it to. Excuse me. Okay. Okay, good. Now, what I'd like to do next is do some kind of so we got triangle fills, triquad fills, fill strategies, and fill checks. Triangulate. I want now to make a function that will randomly kind of, well, how do I want to do it? I want to join. Basically, I want to generate a couple quads inside the mesh. So I want to take pairs of triangles and connect them together. What's the best way to do that, I wonder, is really, that's the question I've got. Well, let's start by doing some simple stuff first, right? Okay, so here, pairing tries, pair tries, something like that. Okay, so let's imagine two triangles. Okay, let's pair them like this. We've got 0, 0 to 100, 0, and then 100, 0, like that. Try A, and then try B is going to be 0, 0, 100, 0, negative 50, no, 50, negative 100 is fine. Okay. So we've got tools cider show el slash polygon of try A. Why isn't that showing up? Oh. No. What? No, that doesn't make sense. Yeah, okay, cider well, whatever. No, it's not a big deal. Oh, wait a second. Did I typo something here? Oh. There we go. That's why. Okay. So these are the two different triangles I want to join together because they share an edge. So let's do defen join tries. Try A, try B. So what it'll return a list, and the list will either be the two triangles if they don't share an edge, or it'll be what am I saying? Share edge. Right, so triangle A and triangle B, all I care about is if they share, if they it's only true if, so first let me let edges be map cat. No, let's do this. Into set, oh come on. Okay, into set the result of concat, and I want to concat, actually no, I do want to do it this way. Partition 2 by 1 Wait a second. Edges, try A. Oh, let's just do that. Edges, try A. Just try B. Right, so then they share an edge if count of edges is 5, because that means, man, I'm losing it today. Okay, so that means, right, because two triangles, if you split them into edges, they've got 6 edges in total. They share an edge if you put those into a set, because a set guarantees that it eliminates duplicates. You could also just do distinct here and then do the same thing. I don't know if it'll be, this is fine. Right, so if I do share edge of try A, try B, it should be true. Good. But if I do try A and try C is 0, 0, 101, so the edge is, it's actually not connected directly, and then 50, 50, false. Okay, that's good. So join tries, I actually kind of wonder if I just do this. So given two triangles, it will no, if share edge, try A, try B. If they share an edge, I want to just return list yeah, I guess that's okay. If I do, let me see this for a second. If I do the hull of concat try A, try B, list, actually I don't even need the list. Wait. Yes, I do. Otherwise, list try A, try B. Okay. Join tries. Try A, try B. Count should be 1. Now, if I do join tries for some different set, right, the count is 2. Let's make them both vectors like that. Let's just try this one more time. Okay. Right, so this is a quad that's returned. So if the triangles are not connected, it just leaves the two triangles alone. Is that how I want to do it, though? Really? Yeah, I guess that's fine. Actually, I should probably just do this. When. So then it's nil otherwise. I like that because I can hold on to the original list of triangles, so it's not like I lose them. Okay, there we go. Right, so now, using that idea, what I want to do is because what I could actually do, it's not necessarily just tries either, right? It could be, I could join a quad to another triangle, right? Like I could start to stitch back any number of these things a few times. So, okay. So I kind of, what I actually want to do is, something like this. Defin get neighbors try, and then a list of tries. Yeah. So for a given triangle and a set of triangles that it's inside, let's do this. We're going to take tries and we're going to remove try from it. Then we're going to filter on share edge, try with all the other triangles. I think that should work. Okay, so let me well, okay, let's try a trivial test here for a minute. If I get neighbors, try A, from the list try A, try B, it should return try B. It does. Okay. So now what I'm going to do is def r points as random points, 200, 200. Let's do 24 points. Okay. So now let's let def tries be triangulate our points. Then let's def A is just nth of tries 3. Let's do I want tries to actually let's redef tries to be triangles from that. And then this, let's actually make it like 8. Right, so we've got A, and then we've got tries. Okay, good. So let's do get neighbors, A tries. Ooh. Oh, hey, Half-Aches. Thanks for the follow. I appreciate that. Just noticed that now. I hope you're doing well. Hope you are well. Just to put a little context into things here. What I'm doing at the moment is trying to do a little bit of work for this art generation tool. I'm trying to make a system that randomly takes triangles and glues them together into quads. Excuse me. Then for the different quad sections, I just have different fill algorithms that I'm working on, basically. So I'm just generating art today is the whole point. Okay. First of all, let's just do this. Count this. Okay. Now, why wouldn't that... See, there's like, a triangle should always have at least two that it's connected to, right? There's not gonna be a is there gonna be a situation where a triangle only shares a single edge? Let me think. Actually, yeah, there could be a triangle with a single edge connection, but there's always got to be at least one that it matches, right? Like, there's never not going to be that. What did I just do? This is not going the way I thought it would. Hello? Please. Ay, 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 ay. Okay, there we go. Let's do 0. Oh, here's what I think might be happening. If the edges are swapped. Okay, so I I have to change this share edge a little bit. Okay. Yeah, so like if I do equal, if the set of point 1020 and the set of 2010, those are equal, right? Yeah, okay. So what I'm going to do here is map set over all of these. That should ensure that share edge will work for edges that are flipped around. I think... Yes. There we go. Perfect. That is fantastic. Let me put a little note here. To check if triangles share an edge, you have to get all the edges. Then make sure you can check for edge equality, even if vertex order is swapped. Simple way to do this is to make each edge a set of its vertices. Then trust that equals 1020 and 2010 is true. Put all edges into a set. The count will be 6 if no edges are shared, or 5 if an edge is shared. There can at most be one shared edge, or all 3 are shared if the triangle is the same. Okay, so that's pairing triangles. That works just fine. Now, what I want to do is create a little what do I call it? Randomly glue tries, then the number to glue. Okay, so given a set of tries, how does it, let's see, if I do distinct let's say take 10 of distinct of repeatedly rand int 100. Oh, I have to do this. Wait a second. Is the count of that always going to be 10? I think it is. Okay, so point of this is let to glue map get from the triangles, this thing here where I do take n distinct of repeatedly rand int of count of tries. Oh, that's messy looking. Well, let's map it. Let's do there. Yeah, that makes sense. There we go. All right. Okay. Right. So what this will do, right, is it'll randomly create it'll give a random integer between 0 and the count of the number of triangles, so it'll never extend beyond the range of the vector containing them. Then it makes sure that it'll run that, it's a lazy sequence, so it'll do it infinitely. Then it makes sure that you pull only distinct values, and then it'll only ever pull the number that you request. So you could pull an infinite number if you wanted to. You could have n be really high, but actually I guess you couldn't, because it'll only have a finite amount of distinct numbers. But anyway, I'm gonna assume that's fine for now. I don't think it'll be a problem really. It might just nil out. Let's check. Wow, okay, so let's do this. Let's let n be let's let n be the min of n and count tries. That way, right, because what I can do, if I do take 10 of randint 10, that gets me all of the numbers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Without freezing or whatever. Perfect. Okay, so I solved that problem. That's good. Although, so this is not going to be perfect technically. Well, let's think about this. Well, let's start with I suppose if I do this, I could do the remaining is going to be how does difference work? Okay, so the difference between, let's do set 1, 2, 3 and set 2, 3, 4. What's the difference? Is it 1? Yeah. Okay, so what I want to do, the remaining ones I want to do set of tries as a difference of set of 2 glue. Okay, so that means that all of the ones I want to glue and all of the ones that can be glued to them are independent of each other. Now that won't necessarily guarantee that there will not be overlapping polys by the end, but it is an improvement. And I'll start there for now, because it's the easier way, and I'm feeling a little bit lazy. So, well, let's just start there, why don't we? Why not, right? Neighbors are going to be get neighbors of try from tries. Then you just do join tries of try and first of shuffle neighbors. That should work. Right, so basically what I want to do here is map cat randomly glue one try from the remaining tries over to glue. Okay, let's see if any of that makes sense. What? Why not? Oh, here. This is where it's... Right, map. Indices like that. There we go. Okay, so let's try randomly glue tries of oh yeah, I want to glue 3. And why is this last one still just a triangle? Sometimes it returns a triangle on its own. Well, okay. I don't think it's perfect, but let's go with that for now and make a little generator for it. Okay, so let's do, we've got tries, let's also do quads. And quads, I want it to be randomly glue tries, and let's make it 9. No, let's do half n That's fine, right? Okay, well, let's go with that for the time being. Fill none. Oops. Stroke red. Quad function. So now let's, over all of this, let's do quad function over quads. Excuse me. Let's not even worry about this. Nor that. Okay, so we want the hull. We want to map quad function, right, over all the quads. Okay, I think, let's try that. Tools, cider, show, gen art 03. Let's do 300 by 420. Okay, I think we're getting somewhere. Let me now okay, so that's promising. I'm trying to follow here. Actually, here, let me do fill blue and then opacity 0.3. That should help. That should solidify where things are. Okay, so there are indeed overlapping points. You can see the different blue colors kind of summing together. Let's do n divided by 6, so it's way less. Let's also make this 30. Yeah, okay, see, this is, there we go. That's starting to feel like what I want it to feel like. We're getting there, I guess, is the point I'm trying to make. But I don't want them to overlap. That's the thing. That's kind of the thing. Okay. Right, so I'm just thinking through this. I kind of probably have to do it like either iteratively or recursively, right? Because every time well, let me not worry about overlap first. Let's do the easier sort of thing first here. Right, what I need to do well, because I'm feeling a little bit lazy, let me first just make sure that I've got a fill quad function that at least kind of works. Okay, I can start with that at least. Let's do quad function is get from quad fill strategies. Quad fill strategies like that. Lines, quad function over quad. Let's bring this number down like that. Okay, that seems to work. Now here I want to do apply. I actually kind of don't want. Let's do here quads, tries, and then here hull. That's fine. Okay, so here let's apply a group to map fill quad over the quads. Right, let's try that. Right, and what I also want to do is this, where something like that. Yeah. Oh. Let's make this B style instead, I think. That's pretty cool. Some of these are still just triangles, that's the only thing. And here I've got that overlap problem. So I do want to fix that. I guess I have to do it recursively instead of trying to map it like I'm trying to do. Well, I'll be right back. I'm gonna get myself a little bit of coffee, I think. I can at least, let's do generate art like this. It's a pretty good start. I will be right back though. Okay. Okay, I have a new idea. Hello? There we go. Okay, so let's try that. Get random neighbor. Nth tries for, no, let's do 12 from tries. And it is a different neighbor. Looks like there might only be 2. Oh no, there's 3. Got 43, 48, 49. Okay, good. Right, so getting one random neighbor is exactly what I want. So what I want to do now is change this up. And how I want to do this is like this. Okay. So I want to set this up like this. Randomly glue tries. Let's set it up. Okay, well, let's set it up like this. So we're gonna have quads is gonna be, it's gonna start as some empty thing. Tries is gonna be like that, and then n is still gonna be like that. So we're gonna accumulate quads, one little chunk at a time. Right, so the first thing we want to do with quads, tries, n is basically well, let's establish the end condition. The end condition is if or if empty tries, that means you've turned everything into quads, or the count of quads count of quads is equal to n. If that's true, what I want to be returned is the data structure quads, which quads I want to do join, I want to map join tries over like this, apply join tries over quads, because I'm gonna accumulate. Wait, no, that's a little bit silly. Let's just return quads right away, like this. Then tries is remaining tries, right? And that should be the data structure. Now, otherwise, I want to let the next tries, well, let's do try A is we get a random one, get from vec of tries, rand int count tries. So we get a random, I mean, let's just do this. Try A is first of shuffle tries. That's shorter. That makes sense. Then try B is get random neighbor from try A and the remaining tries. So I guess it is possible. Okay, so it's possible, right? If from the list of tries, I remove the try that was in the list. Then I filter any that share the edge. And if that's, can I shuffle an empty list? What happens? Okay, and if I do first of an empty list, that's nil. Okay, so get random neighbor can return nil, which is fine. It just means, and if I shuffle something with one, so it will only ever return nil if there are no triangles left for it to get. So that's good. So if there is one neighbor, the randomly chosen neighbor will always be the same, which is fine. That's exactly what I need in that instance. But it can be nil, and that is totally fine. So it just means that what I need to do is I'm just thinking here. Let's assume, right? New quad is join tries, try A, try B. Assuming it'll work. This is, Okay, I have one little idea. So we're going to, across the board, we're going to join try A, try B. We're going to, yeah. Okay, so here, what we do, what happens if I do this? Join tries try A with nil. Okay, so join tries. If you share an edge, it's that. Otherwise, you just return. No, I had this idea. List, that's fine. Otherwise, list, try A, try B. Okay, that's fine. So we'll go here. So quad is that. All right, so then now here you recur, right? Quad, the new quads is map, is concat quads quad, and the new tries is remove the set try A, try B from tries. Does that work? Remove 1, 2 from a vector 1, 2, 3, 4, 5, 1, 2. Yes, okay, good. That is pretty much what I wanted. Vec that. Don't care about hyper efficient code at this point, realistically. And then n is still passed through every time in the recur. Okay, so the only thing I have to check here is in the condition here, what I need to do first is quads. I actually want to modify this a little bit. I want to do, well, first of all, in this one I have to do, in this ending branch, I need to first let quads, let recovered tries be filter from quads anything that has a count anything that has equal 3 count, because that means it's still a triangle from quads. And that is because in this here, join tries might actually return a list of 2 triangles or a list of 1 triangle if it didn't end up joining. And the reason I want to do that is it will guarantee that this will terminate with the list of tries being empty at some point. That's what I'm trying to go for here. I think that makes sense. So recovered tries is that set. And then all I need to do is return quads and tries, where quads is remove nil from quads. And then tries is just going to be concat onto tries recovered tries. I think that'll be good. Let's find out. Oh. No, something went wrong here. Oh, I doubled up here. Okay, so that's that. Okay. Let's see what happens. Alright, so if I run randomly glue tries over my list of tries, and I want to do 3. Okay. Quads. Okay, well, something went goofy here. Oh, of course. Not sure this is entirely perfect, but I'm gonna stick with it at least for now. There we go. Okay, let's try this again. Why is there only one quad? That's the only thing I'm confused about. Well, okay, let's give it a try. So it's returning at least the right lists of things. Now, let's go over here, right, and have a look at tries. Let's do like this. Seed tries is like that. Then quads will be actually, let me do it this way. Let's do mesh. No. Seed tries is good. Like that. Mesh is the result of randomly glue tries, seed tries. Let's do 6. Then quads is get quads from the mesh. Then tries are get tries from the mesh, like that. Then the hull is map point, yeah, hull of the points is fine. Then the try function is like that. Quad functions like that. Okay. Let's see what happens when we do this. GenArt 03. Let's do 400 by 550. 25. Hey, there's quads in there. That's pretty cool. Okay. kind of happy with that, honestly. For now, anyway. Let's do this. Fill lime green, opacity 0.3. And now let's go with yeah, okay. So we got, so the only thing the thing I'm a little bit confused about is I don't always get the number that I put in here. That's all. But let's do divided by n divided by 4. Ooh, that's too much. And there's an overlap problem here still. Now, why would that be? That's a little bit baffling to me, to be honest. Make sure it's an int. I don't think that makes the difference, but let's... Maybe it is working. Maybe it is all working and I'm just getting a little confused. That is very much possible. I think it's looking pretty okay. No, there's something wrong yet. And I don't... Why is that? There's... Is it something wrong with the triangulation? That's what I'm wondering. These overlaps, those are the things I don't quite understand or enjoy. That's the only thing. That's the only thing. Let's assume that it's fixed for now, though. Let's start playing around with the parameters a little bit. I mean, I kind of... I don't know, it's just it's worse than I thought. Why is that happening? Sometimes it looks really nice. Like, it is pretty good. That's the thing. I like it. I like it a lot. It's just occasionally goofing. It's just occasionally goofing on me. Hmm. See this here? Why is that the case? I have to think about it, because I honestly don't know yet. Oh, wait a second. Is it? Let's also split this like this. Idea 3. There. Now at least we're not running over each other with things. Okay, so let's go back to the first idea. Pretty comfortably looking okay. There's no triangle overlap issues, right? That's the thing. Hey, Mini Atlas. Hello, how are you? I hope you're doing well. Fine, how are you? Yeah, I'm good. I'm feeling pretty happy that it's Friday. As you might notice, I'm just working on some generative art with Clojure, just casually working away, you know. I tweeted a picture of what I was working on the other day, and it got a lot of likes and stuff, so that was pretty exciting. And here I am, just kind of expanding the idea a little bit, fiddling with it on stream for a bit until I'm done, and then I just gonna have a really nice weekend, so I'm looking forward to that. So we got this grid thing working pretty well, which is nice. And I've got this one here. Let's see. There we go. That's pretty fun. It's got a few things happening here. We got this random poly sort of thing, and then I've got a variation here where I basically take the randomness out and selected a slightly different line generation fill, and that's got, as you can see, a pretty cool result. Feeling pretty happy with things so far, but I want to change this grid up slightly. Oops. Hello? All right. Good. Right, let's go back to this. Instead of 16, let's just do let's just do 9. That's fine, really. Let's do 220, and I want to make like that. Oh, let's do 03. Grid, we'll make the grid 3 by 3. 230. That should work. Okay, so this one, I have to figure out what's going on. I've got a quad overlap problem. Quad/triangle overlap problem. That's what I'm trying to wrap my head around right now. To be honest, I find it a little bit baffling. Well, let's actually get rid of the fills here, like this, and just stick with that looks pretty cool on its own even. I like it. Okay, but the quads, let's fill with a color. Let's put the tries over the quads like this. What's been new with you there, Mini Atlas? And anyone else tuned in, by the way? How are things going with you all? I hope in general that they're well. Hey, Illusion. You're great. I'm glad to hear it. Long time no see. Yeah, it's been a bit. Last month. Yeah. Last month I was back in Ontario for one of my sister's weddings. Oh, excuse me. So that was a bit of a stream hiatus, but I'm back now, obviously, as you can tell. How am I? Oh man, I'm doing great. Thanks for asking. I appreciate that. Looking forward to the weekend. Feeling really good and having fun with this generative art stuff that I've been just messing around with. You know, it's been a lot of fun so far. This here, I don't understand. Let's try seed tries and see what that looks like. Yeah, just back living the Vancouver lifestyle, which I am always a fan of. I'll hack into your projects any day. What do you mean by that? Do you mean like go on my GitHub and have a look at them? Setup's pretty cool too. Do you mean like in my room? Because I've been I was happy that I was able to upgrade it. I've got let's see here. All these lights are adjustable. Can change the colors and everything. Check it out. Yeah, cool. So this one's called Nebula. Room's pretty cyberpunk. Yeah, that's kind of what I'm going for a little bit, you know? Casual cyberpunk. We got Savannah Sunset. Ooh, that's bright. Let's dim that a little bit there. There's a few things I have to set up yet, like this TV behind me here. I want to get it displaying some stuff. Must be made of solid state physics, which I studied. Yeah, I don't know about any of that. Where'd you buy them? In the software? Oh, these are Philips Hue bulbs. They're just Bluetooth bulbs that you can get at like Best Buy. And then it's just an app. It's a very simple setup. And this, if you mean software that I'm like programming in, this is just Emacs running Clojure and my own libraries. And that's the whole deal, really. But yeah, the bulbs, super simple. Let's actually go like this. There we go. This one here, this rectangle, I'm not done with this either. I have an idea for putting something in there. But I built that. So you can get these strip Bluetooth lights as well. So what I did, I bought a strip, and then I bought some tube, like it's not PVC, it's like it's some kind of plastic from Home Hardware, and I just built a frame and put the LED inside the tube, so you get a pretty cool sort of light frame. That was pretty fun to make. But as you can see, I want to set it up a little nicer, kind of clean up the wiring, have sort of a cool display inside the middle there, maybe like a sign, or I have an idea for a sort of light sculpture kind of thing. Anyway, that's tangential to me trying to figure out this little problem I've got here. Basically, I just don't quite understand but it's the genius rest, you take it to solve things. I don't quite know what you're referring to. Sorry, maybe I just misunderstood exactly what you meant. Do you mean it takes like effort to solve things and like do what I've done with the setup here? Is that what you're talking about? If you're suggesting I'm a genius, I mean, I appreciate the compliment. I can promise you that I am not a genius, though. Just a regular guy. Just some dude. But hey, I accept a nice compliment. That's I'm assuming it's a compliment. Oh, I see. Took a tangential. Yeah. Yeah, I'm working. I'm talking tangentially. Hopefully, my brain's still working on the problem, I guess is what you're trying to say. Hopefully. Fingers crossed. We'll see. We'll see. Let me. Brain doesn't stop working on the problem. Yeah, I guess that's true. Although, like, there is something to be said about having to focus on things, right? That's the only thing. So, I'm pretty sure the only thing going wrong here is. Well, let me try this. I hope for that too, and I stay for hours on in tangential matters. Yeah. I get it. I get it. It's this function here, randomly glue tries. I think I've got some faulty logic with Let me just do this. Let's not recover any triangles and see what happens then instead. I also did something wrong here. Tries like this. Almost. So this is wrong here. But it's looking a little bit better. Actually, I have to wait. No, let's stay with A. And we want to do this. Oh, that's... I mean, it's getting better. It's still not right, though. What happens if I set quads to be like really high? This might break. Never mind then. Okay, well, let's try one other thing. No, see, we're back to the same problem now. This looks pretty cool, though. I mean, like, it's very close to fine, so I'm not too fussed. But it just does occasionally screw up the lines. That's the only thing. So it does matter. It matters, but I'm feeling very close, which is good. I think I'm gonna give myself about half an hour. just to mess around, you know. I actually thought of one final. No. Let me get this sorted out. Let me figure this out. Okay. So here. Oh boy. Oh, 1 second. This is an important message. Gotta read it. All right. Hmm. Okay, so why hmm. So this, if try B is nil, that can happen. Then join tries, try A, B. Let's just do it this way again. When, let's get rid of this. Okay, so there should never be still have this. But why? But why? Randomly glue triangles. Let's give tries and let's do 7. Okay. Quads. 1, 2, 3, 4, 5, 6, 7. But why on earth is there a triangle in there? That's the thing I don't get that. Okay, let's figure it out. First of all, let's actually not even remove nil. Let's see if that gives us anything different. Okay, so there, it never is nil. It should sometimes be nil, right? Oh, wait, what have I done? This function doesn't even exist. Or, I mean, it exists, it's not even used, is what I meant. So let's clean that out of there. I wonder if there is actually a problem with my join tries situation here. When they share an edge, Could it be? Oh, okay. I think I know. I think I know what's happened. I cannot actually do the hull because the hull, it, here's, okay, I just got it now. So here's the deal. It's possible that I have a triangle connected correctly to another triangle, but the polygon it creates would not be convex. You can have two isosceles triangles connected like this, and then the hull is an incorrect connection between the two. What I have to do instead is well, that's the thing. I have to chain the edges together and remove the edge that's shared amongst the two. So how do I do that? The hull is not the right answer, is the simple truth of the matter. Huh. Who would have thought? That is exactly what has gone wrong. And that's why it only overlaps sometimes, and that's why you get lines over it sometimes, because the connected triangles... Ah, there we go. Okay, that is exciting. Okay, right. How do I want to do this? Right, okay. Let me think about this. Can I might be able to cheese it, actually. Okay, here's an idea. When share edges, let edges No, I don't want to do it that way. How do you do, it's not partitioning. I don't want to partition. I want to do, group. Does this work? 1, 2, 3. 1, 2, 3. 1, 2, 3. Ah, wow, that's cool. Okay, group by identity is what I want here. Then no, I don't want edges actually, I want vertices. So vertices is concat try A, try B. Right, so if I do group by identity concat, oops, try A, try B. Okay, this is weird, but this is how I'm going to do it. You get the vertices, then you get, well actually, let me just right away do group by identity. Let's call it point groups. Okay, then, so the point groups, if I do vals of that, yeah, and then sort by count, yeah. Okay. This is weird, but this is exactly how it's going to be. A, B, C, D is sort by, no, actually it's A, C, B, D, sort by count of vals of point groups. Okay. So this is weird. So the logic of join tries, I'm going to turn triangles into vertices. The shared edge means two of the vertices will be will exist twice in the list. Get this by vals of group by identity. Actually, let me just double check this. Can I just do group? 1, 2, 1, 2? No. Yeah, I don't know how that works. Whatever, let's not worry about it. Okay. We know that the correct order of vertices will always be starting with a non-shared vertex, going to a shared, then non-shared, then shared, closing back at the start, non-shared. Thus, sort by count of the vertex groups will tell the first and third points, single count, count 1, and then second and fourth, count 2. All right, that's maybe confusing. Also, does it work? That's the it's kind of the big thing here. Right, so that's the let. Then all I want to do is return A, B, C, D, like this. So it just swaps the order there. So if I join tries now, join tries of try A and try B, it does appear to work. Although, let me double check this. Oh, no. I have to do map first over that to get the right. Promising, very promising. Now, let's oops. Instead of try B like that, let's do 0, 0, 100, 0, and negative 70, negative 100. Yes, okay. It's working. All right, now let's see if that is actually going on, if things are working the way I expect. Uh-oh. Oh, right, list. Okay. Okay, that all seems correct. Ooh, let's go. Okay. On first visual inspection, it seems correct, but oh yeah. Look at this. So this is where this would have shown an issue. This would have been an issue before, but this is fine. Yes. Okay. I'm pretty sure I've solved the problem. Yes, I love it. Oh man, that's great. That makes me happy. Okay. Oh, I spoke too soon. This is wrong here. It's a step in the right direction, though, for sure. Okay, but with that, I should... Yeah, okay, so there is null in there. Right. Wait, what did I miss here? Oh, did I accidentally... Must have got rid of an if statement or something like that. That just... Okay. What if I go here now and I make this n? So it'll always be the maximum number of quads. It should work. Why not? Maybe because of that? Cool, okay. Yeah. Yeah. Mostly makes sense. I am quite pleased with how these are starting to turn out. Uh-oh. Oh, okay. I think I know. The only time there's ever visual overlap is here, and I think what's actually happened is when I run, yeah, I think what that is let's do fill quad check. Okay, so here I want tools, cider, show, quad, fill, check. I want this last point to be I want this to be concave. No, not inverted, not like that. That's wrong. Okay, something like that's pretty good, but let's move this like this. Okay, good. Yeah, okay, that's what it is. So, okay, here's why things start to look overlapped and weird, because the strategy for all the quad fills are they have been assuming a convex polygon, but that's not guaranteed to happen, because here especially I can glue two triangles together that result in a convex poly, which is totally fine, except that it now results in these overlap portions. So that may be a problem. Well, okay, but I have a really quick way to check if a polygon is convex or not. Here, I can check equality between the hull and the original poly. So let's do that. Right, let's go here. Let's do okay, so here what I need to do is, it's true if it is convex if and only if the set of hull of points like this is equal to the set of points, right? So here, convex, right? If I do convex try A of wait, what? Uh-oh. that's no good. Well, okay. That's a little note for myself, I guess. I have to figure out why hull doesn't work on sets of 3 points, like triangles. It should work just fine. That's a bummer. Okay, little note to self. Let's save this though. Okay, I gotta get going. I just have to write down a little note to myself here. Okay. All right, that's all. I gotta get going. I'll be back again on Monday. Thanks everyone for tuning in. Thanks people for chatting. Nice casual day. Thanks for just being around while I was just going slow and thinking through my work and that sort of thing. So that's gonna be it. I'll be back on Monday. Thanks everyone. Have a good one. All right. Bye bye. Bye bye. Bye bye. Bye bye.